In this example, we're going to solve this radical equation, and it looks like we have the square root of 2y plus 3 over here on the right side, but we also have this minus 2 along with it. So remember, the first step in solving these types of equations is that we need to get this square root expression all by itself on one side of the equation. Well, it almost is, except I have the minus 2 along with it. So we'll go ahead and start by adding 2 to both sides so we can indeed isolate that radical all by itself on that right side. So it looks like y plus 2 equals that square root of 2y plus 3. Okay, so what can we do now to get rid of this square root? Well, what's the inverse operation of the square root? Well, it's squaring something. So we're going to go ahead and square both sides of this equation. And on the right side, that's really nice because the square and the square root cancel each other out. So we'll have just that 2y plus 3. On the left side, however, we have this y plus 2 quantity squared. So this is going to be a binomial that we need to square. So we can get y squared plus 4y plus 4 whenever we square this binomial. All right. So it looks like we have now a nice quadratic equation. So we have the y squared with a couple of y terms and a couple of constants. So let's get everything on that left side equal to 0. So we'll subtract 2y from both sides, and we'll subtract 3 from both sides as well. So everything on that right side will now cancel. So y squared plus 2y plus 1 equals 0. And it looks as though this will factor nicely. So y plus 1 and y plus 1, they're both the same. So since they're both the same, we can use this 0 property of multiplication and just say y plus 1 equals 0, which means the value we have here is y equals negative 1. But remember, this is only a possible solution because sometimes when you are solving these square root equations, you can get extraneous solutions. And those appear whenever we're squaring both sides because we open ourselves up to the possibility that some of these values might not work. All right, so let's take this y equals negative 1 and let's plug it back into the original equation and see if it works. So y equals the square root of, so 2y plus 3 minus 2. So negative 1 equals, so we have 2 times negative 1 plus 3 minus 2. So negative 1 equals, well, what is 2 times negative 1? Well, it's negative 2 plus 3 is 1. What's the square root of 1? Well, that's 1. So negative 1 equals 1 minus 2. So negative 1 equals negative 1. Yeah, so this works out great. So we can see that the solution then for this equation is indeed y equals negative 1. We solved this by isolating the radical on one side of the equation. We squared both sides and solved. But just because the solution is what we got here, y equals negative 1, doesn't mean it's going to work. So we plugged it back in to ensure that it works, and it did. So here we are with our solution y equals negative 1.